Hello everyone, I am Dr. Sirajul Akfaizi. I welcome you in my YouTube channel. Today in this video, I am going to some knowledge related to carbohydrates. You know, my friend, carbohydrates are broadly defined as polyhydroxyaldehyde. Polyhydroxyaldehyde. What is meaning of polyhydroxyaldehyde? Poly means many, hydroxy means OH. So polyhydroxy, बहुत सारे OH and aldehyde CHO functional group or ketones and their derivatives or as substances that yield one of these compounds. You know, my friend, composed of carbon, hydrogen, and oxygen. In carbohydrate, if you if you see the formula of any carbohydrate, you will find carbon, hydrogen, and oxygen. And functional group present include hydroxyl group. Hydroxyl group. OSE indicates sugar. OSE OSE indicates sugar. Now, carbohydrates are most abundant of all organic compounds in nature. In plants, energy from the sun is used to convert carbon dioxide and water into carbohydrate glucose. Many of glucose molecules are made into long chain polymers of starch that store energy. About 65% of food in our diet consists of carbohydrates. Each day we utilize carbohydrates in food such as bread, pasta, potatoes, and rice. Other carbohydrate called disaccharide, including sucrose, table sugar, and lactose in milk. During digestions and cellular metabolism, carbohydrates are converted into glucose, which is oxidized further in our cell to provide our bodies with energy and to provide the cell with carbon atom for building molecules of protein, lipids, and nucleic acid. My friend, in plants, a polymer of glucose called cellulose builds the structural framework. Cellulose has also important uses. The wood in our furniture, the pages in your notebook, and cotton in our clothes are made of cellulose. So, functions of carbohydrate in cell. Major source of energy of the cell. The second important point, you have to write it down. Major structural component of plant cell. Immediate energy in the form of glucose. Reserve or stored energy in form of glycogen. So you can see the structure of glucose, aldehyde and polyhydroxy. You can see galactose. You can also see the ketones. Now, classification of carbohydrate. Carbohydrates are classified according to the number of subunits that make them up. Three types of carbohydrate: monosaccharide, oligosaccharide, and polysaccharide. Disaccharide, trisaccharide, and tetrasaccharide. So, monosaccharide. What is monosaccharide? Monosaccharide are simple sugar or the compounds which possesses a free aldehyde CHO or ketone CO group and two or more hydroxy group. They are the simplest sugar and cannot be hydrolyzed further into smaller units. Monosaccharide contain a single carbon chain and are classified on the basis of number of carbon atoms they possess and as aldoses or ketoses, oses and ketoses depending upon their group. So you can see the monosaccharide classification by or on the basis of carbon atom. Sugar triose, 3 carbon. Tetrose, 4 carbon. Pentose is 5 carbon. Hexose is 6 carbon. Structure formula C3H6O3, C4H8O4, C5H10O5, C6H12O6. Example: triose, glyceraldehyde. Tetroses, erythrose and threose. Pentoses, xylose, ribose, arabinose. Hexoses, glucose, galactose and mannose. Now ketones, dihydroxycetone, erythrose, erythrulose, ribulose and fructose. Now monosaccharide, hexoses, glucose, galactose and fructose. D-glucose, dextrose, blood sugar. D-galactose, D-fructose, levulose, fruit sugar. So glucose, you can see the structure of glucose, galactose and fructose. Fructose is entirely different from glucose. Here you can see the 5-member ring, in glucose 6-member ring. And galactose, you can see the differences. Where is the differences in the glucose and galactose? This is very important point. So you will find the positions, you can see here this and this. Then you will understand the difference between glucose and galactose. Now stereochemistry. Optical isomers, enantiomers, differ from each other in the disposition of the various atoms or group of atoms in a space around the asymmetric carbon atom. You can see here D-glyceraldehyde and L-glyceraldehyde. So you can see the D-glyceraldehyde, then 4 carbon, then 5 carbon, then 6 carbon. Now properties of monosaccharide. Reducing sugar or non-reducing sugar. This is very important. You have to know. Carbohydrate with free carbonyl group or hemiacetal form give a positive taste to Benedict and filling reagent. Without having been hydrolyzed are referred as reducing sugar, and other the acetal types are then non-reducing sugar. So what is the difference between reducing sugar and non-reducing sugar? Reducing sugar carbohydrate with free aldehyde at carbon 1 and free ketone at carbon 2 groups. They are in hemiacetal or hemiketal form, do exist mutarotation, do form osazone with phenylhydrazine, do form oxime with hydroxylamine like glucose, fructose, lactose, maltose and silobiose. Non-reducing sugar like aldehyde or ketone group is not free but instead utilized in bond formation. They are in acetal or ketal form, do not exhibit mutarotation, do not form osazone, do not form oxime. For example, sucrose, glycogen, insulin. This is very important for the exams. What is the difference between reducing sugar and non-reducing sugar? Now oligosaccharide, you know these are compound sugar that yield 2 to 10 molecules of the same or different monosaccharide on hydrolysis. Accordingly, an oligosaccharide yield 2 molecules of monosaccharide on hydrolysis is designated as the disaccharide, and the one yielding 3 molecules of monosaccharide trisaccharide, and so on. So disaccharide examples: sucrose, lactose, maltose, silobiose, tetralose, gentiabiose and melibiose. Trisaccharide, tetrasaccharide, pentasaccharide, and the molecule composition of the 3 lysiums oligosaccharide, raffinose, stichiose and verbascose is shown, you can see here. So maltose on hydrolysis give glucose. Lactose on hydrolysis give glucose, galactose. Sucrose on hydrolysis give glucose and fructose. Now disaccharide, have you have seen already, glucose plus fructose, sucrose. So table salt found naturally in plants, sugar cane, sugar beets, honey, maple syrup. Sucrose may be purified from plant source into brown, white, and powdered sugar. Glucose plus galactose, lactose, and glucose plus glucose maltose. So glucose plus glucose maltose produced when starch breakdown, used naturally in fermentation reaction of alcohol and beer manufacturing. So you can see sucrose, lactose and maltose structure. Now trisaccharide, compound of three monosaccharide raffinose formed by 1 mole of each glue, fruct and galact. So tetrasaccharide styrose composed of 2 or mole of galactose, 1 mole of glucose and 1 mole of fructose. Now polysaccharide containing 10 or more monosaccharide units attached together. For example, starch digestible, glycogen digestible, fiber indigestible. Long chain of glucose unit form these polysaccharide. So the great majority of carbohydrate of nature occurs as polysaccharide. So chemically the polysaccharide may be distinguished into homopolysaccharide and heteropolysaccharide. What is homopolysaccharide? Which yield one on hydrolysis a single monosaccharide, and heteropolysaccharide which produce a mixture of monosaccharide on hydrolysis. Based on their functional aspect, the polysaccharide may be grouped under two heads: nutrients digestible polysaccharide, structure indigestible polysaccharide. Now, types of polysaccharide, you can see the starch, amylose, amylopectin, cellulose, glycogen. So this is the concept map. Carbohydrate are classified as monosaccharide, disaccharide and polysaccharide. And then you can see include maltose, lactose, sucrose, reducing sugar. So my friends, monosaccharide examples you have already seen. Disaccharide, maltose, lactose and sucrose. This is also important. Maltose contains glucose, lactose contains glucose, galactose and sucrose contains glucose, fructose. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.